The second lesson in chapter 6 is volume, slicing, discs, and washes. These are different methods we will use. The learning objectives of this lesson are compute volume by means of definite integration using areas of cross section, find the volume of solid of revolution using the method of discs, and find the volume of solid of revolution by using the method of washes. We will go through all these different methods. So over here, you must remember the disk and washer. A disk is something like this. A washer is having a hole. So the formula changes. And we will come across this one by one. Please watch the videos in continuity. After the first video, go to the next. Don't jump the videos because you need the information and the knowledge of the previous video to understand the next one. So please watch all the videos in this lesson and you will be thorough with all the three objectives. The keywords in this lesson are volume, slicing, washes, discs. You will come across these. Now before we begin with the example problems, let's quickly go through the basic introduction. I've not done any derivations and in detail, but just the basic things to understand this lesson. Volume of by slicing. What does this mean? So now, first of all, it depends on the shape. Whenever you solve the problem, it depends on the shape. But over here, area in this particular cube differs length and width. Over here, it's a cylinder, it differs, it's pi r square. But the volume basically is all the three dimensions multiplied, length, width, and height. Over here, you have pi r square into height. But how can you relate these both? See, you can see something is common. The volume will always be area times height. We already know this. But what you need to understand over here is height is required. It's a constant. It's always there. Area is there, but area differs. See, in this case, it's length into width. Over here, it's pi r squared. Now, if you find the area of different objects, then that is enough. Whenever you see a given object, see what is the area, function of area. Then use the formula, you can get it. Now, over here, the area we are talking about is cross-sectional area. Now imagine you won't be finding all this area, this not the surface area, this one cross-sectional area like this. See now this, it's like minutely small one circle over there, right? See now this top surface, only this top surface. This is the cross section only at this. Now the best way to understand this would be if you cut this, okay, small, very small, thin slice, that area we need, the cross sectional area. Okay, over here we can find this pi r square, and then when you multiply this total height, you will get the total volume. Okay, so now one other way to understand is volume is basically how much water that can be filled inside. Okay, so this is the area, cross sectional area, and total height will be the total volume. So that's the thing. Same way over here, you can relate that over here as well. Now let us see this, the formula which we use, volume by slicing. Over here there is lots of derivation, but if you remember this formula, it is more than enough. Over here you're cutting into different intervals, small intervals, and then when you integrate it, you will get it. So now you basically reduce this into small intervals, that is dx. This is basically the height or thickness. Okay, a of x is area. See, in the previous one we got it right, area into height. So the same thing over here, volume will be integral from a to b, from the given limit, for the given interval a of x dx. So if you use this formula, we can solve the coming problems. In the next video, we will start solving problems and you will understand how to apply this depending on the different questions. We will solve the first problem, that is computing volume from cross-sectional areas. Now over here we have a problem, that is the Pyramid Arena in Memphis has a square base of side approximately 180 meters and a height of approximately 100 meters. Find the volume of pyramid with these measurements. The figure is given over here. There are various methods to solve this. Now, which I'm teaching is one of the method, and I feel this is one of the easier method and simpler method rather than solving a lot and getting the answer. Now, if I'm showing you 1 second, I'll just show how much is this. Just finding the S equation, that is the side equation, area, substituting the value, and you'll get the answer. This is much concised way of solving. We will solve one by one. Now, before we go to the step one, I want to tell you a few things. In these type of problem, you must see what is given in the question. Here they have told square base. Now, area of square is side to the power 2. So you should know it's side square. If it was, say, circular base, then it will be pi r square. If it is rectangular, then length into breadth. It depends on the question. It will be mentioned in the question. Okay. Now, this one over here is a square pyramid. It will not be as conventional problem solving because it's not exact coordinates. You can't just put this as 0, 0, 0, 1. Now, you need to apply a lot of things over here. You know, because this is a square pyramid, this is a 3D object, you need to understand this in a different way to get the coordinates. So, analyzing the graph, that is this, diagram, analyzing the figure, find the coordinates at the base and the topmost height. Okay. Now what it says is, what is this coordinate point? Now over here you must understand the side is 180. Okay, the side is 180 meters, but the height is 100. From here to here, the straight height is 100. So let's write the coordinates. Over here, see, this is the x, right? They are mentioned over here. So let us take the height as, don't get confused over here, since this is mentioned as x, we'll take this as the height. 100 meters. And now this point is like a, if you see like a 3D view, this will be basically 0. It's the beginning. Okay, this is the beginning. Now over here you're getting 100. This is 0. Now let's just see like this. This is the height. So this is upwards is the x over here. So 100 is written over here. Now over here you're starting the values. So this is the initial 0. Now what is happening over here? It's 180. Why? Because the side is 180. From here, when you're going to over here, this value, which is 0, will increase to 180. But now here you're going downwards, so this will be again 0. Okay, so it's going downwards. You must see like this, downwards. So the topmost height 100 comma 0, because this is the initial point we are considered, and this, the side is 180 but height is 0, bottommost point. So another way to understand is topmost point height will be 100. Okay, and then the side distance is 0. Here bottommost point 100 base, right? 0 is the height, and then this is 180 because x is upwards. Now this just varies because it is a three-dimensional object. Now the sides of the square base must be a linear function to be solved. Now here you can see it's a straight line, linear functions, right? We know linear function is given by y is equal to mx plus b, where m is the slope. If you find this equation, that is the side, then you can easily square it up to find the area. So to find the cross-sectional area in the step 2, first you need to find the slope. How do you find the slope? By using this formula, y2 minus y1 divided by x2 minus x1. Now let us apply over here. See, this is the initial point, so I'll take it as x1 y1, x2 y2. Now what do we do? Apply in this formula. When we apply, we will just see it is 0 minus 180, y2 minus y1, 0 minus 180 divided by 100 minus 0. The answer is over here negative 9 by 5. Now apply it over here in this particular equation. Okay, this is simple. For starting part, side, that is side, 9 minus 9 by 5x. But what about this 180? This is the intercept, y-intercept. When do you get y-intercept? When the first value is 0, isn't it? Now there are other methods to solve, but since it is directly given over here, just substitute, just see over here, the first value is 0. Whatever is the answer, that is the y-intercept. Otherwise, you can use test values. Okay, you can just substitute over here, y as 0 and x as this point, and then solve it. You will get the answer. But since you know this is the intercept point, okay, that is the answer because this is touching the axis. That is 180. Always remember, when the first value is 0, the next value, that is the y-intercept value. Next, what would be the next thing? Area A of x is equal to s square. This is given. This is the given equation. That is the side. Sorry, this is not the given. This is the side. Over here, A of x is required to be used in the formula. So area of a square is side square. What I meant by given is the square is given. So we need to use s square. It is mentioned in the question. So we are using side square as area. The area equation is found out, so square it up. Now all you need to do is substitute in the formula. So a to b is the interval a of x into dx over here. Now what is the interval? See, from here to here, the dx, right? The height. It's basically you're finding the cross section. See, like this. There are from where to where? From 0 to 100 you're finding, right? So that's why the interval is from 0 to 100. And then the area equation is found out, and put this in calculator directly and you can find the answer. Or you can solve it using the formula which we have used in the last lesson. In the previous video, in one of the problem we had solved by using formula, same type. Or you can directly use calculator. Over here, this symbol, open the bracket, minus 9 divided by 5 plus, okay, I forgot to write the x, alpha x plus 180 the whole square. And over here it's from 0 to 100, and that is the answer. It is, the volume is 1,080,000 meter cubes. So this is the answer. Why? Because the units is in meter. Similarly, let's solve one more problem, computing the volume of a dome. Over here they have told, suppose that a dome has a circular cross section. In your mind you must remember, this is area is pi r square. This is given with outline y equals minus 2 by 45x square plus 90 for negative 45 to 45, the limit of x, in units of centimeters. The graph is shown in the figure. Find the volume of the dome. So this is the graph given. We need to find the volume of this dome. Now look over here. In this problem, there is a little bit of difference because the circular cross section, we have to find this entire volume. Now when we see the cross section over here, see this one, this is the cross section they are given. What is happening here? This is the part you're finding. So you need to find all the cross section along this point to this point. Okay, so if you cut this like this into various points, basically you're integrating. See, one, if you find one, it's enough. From where to where? You're integrating from 0 to 90. Okay, in this case, see, this is the cross sections. For all these, you need to integrate. If you find one part and integrate, that means you're finding all over here, all the cross sections, sum of that. So the what you need to remember, don't just go with this limit. Oh, the limit is 45. No, you need to take along the y-axis. That is very important. Now, we will just solve the problem. You'll understand better now. Analyze the graph. The cross section occurs along y-axis. This is the main reason. Now, in case if the graph was like this and you are to find the volume, then yes, this and this would be the interval along the x-axis. But now it is along the y-axis, isn't it? The cross section over here, see? This one, this is the radius from year to year. So remember, we need to change the question, everything, even the formula will be changed. It won't be a of x, it will be a of y. Why? Because this axis is used. If it was like this problem, then yes, we would have taken a of x. That is the difference in this case. So now over here, the limits will be from 0 to 90, okay? And we have to integrate with respect to y. This is one more crucial thing. To find the cross-sectional area, y is equal to minus 2 by 45x square plus 90 is given, but this is not the thing. You need to rearrange Take x to one side and y to the other side. Why? With respect to y, we will solve a of y. That means x is equal to in terms of y over here. So take everything to the other side and simplify. We are just doing basic algebraic calculations. Over here 90 minus y, this to the other side. Take the 45 and 2 to the other sides and take the square root of this. That's it. Very simple. Now, this is basically the radius, okay? So now this, whatever is given is mentioned, this is the equation. Now, what do we do? Now, all we have to do is put it in the formula of area. Pi r square. Now, r is found out. This is the r equation. So this will be your equation for the area. A of y is equal to pi into this radius, the whole square. Now you need to use the formula and solve, but in this formula, the interval a to b is 0 to 90. A of y, what is this? Substitute over here and dy. Put it in the calculator. Very, very simple. Just now what we did, same thing you need to do, just that use the brackets properly. Okay, just sorry, over here. This shift pi and use the brackets, use the square root appropriately. This 45 divided by 2, multiply it with 90 minus, instead of, you can't have dy over here, just use it x, but you must know that is y over here, and use the bracket appropriately and then square, and the limits are from 0 to 90, and this is your answer. That is basically 28627. That's how we can solve it. Very simple, very straightforward. Just remember which axis you're integrating. That's how you can directly use a calculator, but the formula changes depending on the axis. The next topic is the method of disks. Here you will be given a function, say like this, the limit a to b, and this is the function. Now you will be asked to rotate this, then you will form a disk. Now what does it mean rotating is this function will be rotated along this x-axis. Okay, we will have to rotate it along y-axis as well, but now let us only focus on the x-axis. This is the axis. This function will be rotated like this. It will look like this. Now you can see when it goes down and it turns up, you will get this shape. This is having circular cross sections. Now you can see the same function a to b, but when you rotate it, you get like this. It is made up of many circular cross sections, right? So what you can do is you can find the volume very simply by using this formula. The limit is required until where you need to find the volume. From this point to this point, that is a to b, pi, f of x, that is the function square. You need to square the function. It's pi r square. Now, if you look closely, look at this. This is the function. So what is this? This is basically this line. So what is this line? That is the radius, isn't it? So that's why radius square or the function square, in simple terms, whatever the function is given. Why? Because you're rotating it along the x-axis. So that function at that particular point will be rotated. That will be the radius times dx. If you integrate this, you'll get the answer. Same way, you can try even rotating around the y-axis. Now over here, when you're rotating this function along y-axis, what happens? You will get this. It's again circular, but now we are doing along y-axis. So let us see. This is a circular cross section. Over here again, this limits in the y-axis limits c to d pi. Now this is the radius, the function gy square dy with respect to y. We will see a problem you'll understand much better now. Rotation about the x-axis. Now, okay, this is just a quick review of the formulas to see. See, when you're rotating along the x-axis, it's something like this. This will be given function. Rotated, you'll get this. This is the formula. For y-axis, this is the formula. Now we will see an example problem. Revolve the region under the curve y equals square root x on the interval 0 to 4 about the x-axis and find the volume of the resulting solid of revolution. Now, basic thing, we have done this since the last lesson. So please remember, it is continuation of the previous lessons and the previous video. So if you have not watched the previous lesson, please watch it and then continue over here. We had learned how to graph in the previous lesson. So with basic knowledge, let's graph it. Now, you know this is a square root function. Square root function starts from 0 over here and it just goes like this. Now, over here, the radius is basically this function, square root x. Okay. Now, when you rotate it, it'll be something like this. So you can see. What do we do? Substitute the values in the formula. That's it. It's very, very simple. But what is the limit? It's given 0 to 4. So a is 0, the smaller value. B is 4, the bigger value. Pi is constant in the formula. F of x means the function, that is root x, the whole square dx. Now, you can solve it using formula or you can just use the calculator. You can use this symbol, pi, shift and this, shift and this symbol over here. You'll get pi, multiply it with, you can use the brackets because you're squaring. It is square root alpha x. Close the brackets and square it up over here. It's from 0 to 4 and you'll get the answer 8 pi. So that is the answer, or you can even just press this and get the units. So square, it is, okay, there is an error over here. I'm sorry, I apologize. It is unit cube. Volume is always to the power 3 because there are 3 dimensions. Please note, area is unit square, volume is unit cube. I will make this change in a while. I'm sorry for this, but please remember. So we will do the next problem as well. Find the volume of the solid resulting from revolving the region bounded by the curves y equals 4 minus x squared and y is equal to 1 from x is equal to 0 to x is equal to root 3 about y-axis. So now if we see this, it's what? A parabola, negative parabola. So it'll be like this. But this 4 denotes it is having the y-intercept at 4. So if it's like this, this is 4. Okay. And the line y is equal to 1. So this is being revolved. Let me show over here. So this is the part. Now this is being revolved, isn't it? So now over here they have taken limits of 0 to root 3. So one second, I'll just show. I've drawn the entire figure. This is the parabola when it is 4 minus x squared and y is equal to 1. But what are the limits of this graph? It's not the entire limits. Now, whatever I have drawn is in the negative side. No, you have to take from 0 and this part over here which touches is root 3. Okay, it will be 1.7 something. It's less than 2. Now, this is the value 0 to root 3. Only this part of the graph is considered. So when we have such case, it is very hard if you do it along x-axis. Why? There is a gap over here. It's hard. So now in such cases, it's very easy to use y-axis revolution. And it's also mentioned over here, do y-axis. But otherwise, you must understand, it's easier if you do y-axis. So y-axis revolution would mean it'll be something like this. So this part, when you revolve, you will get this. So we need only this region. Can you see? From here to here. Like, I mean, from 1 to 4. That's the only region. From 4 to 1. Nothing else. So let us find the points of intercept. Let's write the equations in y first. In terms of y, what I mean is, because we are revolving around y-axis, even in the last lesson, when we revolved around y-axis, we had to write all the equation in terms of x. In terms of y, that means x is equal to all terms of y at the right side. That is, x square, when I take it to the other side, will be 4 minus y. But you need to remove the square root, so take square root. This would be the answer. So you're writing in terms of y, that means x at one side and equal to all the terms at the other side. So this is it. So this is the given equation. So rearrange and write it like this. Now you need to find the limits. If you have drawn the graph, you can easily understand the y limit. It starts from 1. One limit is already given. What is the other limit? From this graph, you can see y is the intercept. So over here it is 4. Otherwise, You can see at x is equal to 0, what is the y value? X over here is 0, isn't it? So put x is 0, what is the y value? Square it on both the sides, you will get 0 is equal to 4 minus y is equal to 4. So the limits will be 0, 1 to 4. Why? Because 1 is given. Y must be greater than 1, but less than or equal to 4. Substitute in the formula. This is the formula. Limits are from 1 to 4. Pi, the function is given over here. This is the function, square root 4 minus y dy. Look, the formula will have, with respect to y dy, that means all this function will be in terms of y. Variable is y. Put it in the calculator and you'll get the answer. So let's just double check. This symbol over here and then pi. Sorry, again I used alpha. Sorry for that. It's pi. Open the brackets. It is 4 minus, there is no y symbol, so you use x itself denoting, but you need to know that you're solving this. Any variable in this calculator, you use x itself because only this option is for dx. That's it. So, okay, I have made a mistake. That is, I did not use the square root. Now it is 4 minus, this is supposed to be y, close the bracket and square it. And the limits are from 1 to 4. The answer is 4.5. 9 by 2 is 4.5 pi or 14.1314 unit cube. Again, I've made the mistake. I'm sorry. I will change this error in this PPT and re-upload it. But please note, this is cube. Volume will always be in terms of cube because there are 3 dimensions. Similar to the method of discs, we have method of washers. Washer means something that has a hollow space in between. Now, this is a circular cross section, but you can see a hollow space. So when we find the volume, we need only the volume of this space, not the hollow space. So what can you do? One thing is you can find entire volume and subtract the hollow volume. So how do we do it is very simple. Find the total outer radius. Using the outer radius, find the total volume. Okay, say this is 2, so radius will be 1 and solve it up. Then you can minus the volume of whatever is inside. Volume I'll put because that's inside. But now we are not going to apply the formula separately and solve. We will just do it in the formula itself. I will show you now. See, when you rotate along the x-axis, you get this washer. So what you do is pi r square is integration of pi r square is the volume. But over here, what we do is pi is out from integral wherever we want a to b. The outer radius square minus the inner radius square, we do it together. So we will get the volume of only the washer, not the hollow space. So r square, outer radius square minus inner radius square. Then we will remain with only the outer volume. Same way for y-axis, we just now saw y-axis problem. Even in the last lesson, we saw y-axis problem. What happens is everything will be with respect to y. And it's again the same, outer radius minus inner radius. We will see a problem now. Capital R is the outer radius, small r is the inner radius. Here we are getting, let R be the region bounded by the graphs of y equals 1 by 4x squared, comma x is equal to 0 and y is equal to 1. Compute the volume of the solid form by revolving R about the y-axis. This is important. It's along y-axis. First, we need to sketch the graph with our basic knowledge. Over here, you can see this is parabola. Parabola is something like this. Sorry, that is a very bad parabola. Now I'll draw, okay, parabola. Again, anyways, I hope you understand this is a parabola. But you are dealing only from x is equal to 0. So since there is no plus or minus, it will be at 0. This is at 0. So you're taking only this part. Okay, that's the reason. And they have told y is equal to 1. So where is 1? This is y-axis 1. Cut it over here. So only this region. Now look at this. If you rotate it along y-axis, do you get a washer? No, this is just like the previous video where we saw computing volume, the method of disks. So see, this is what we get. We did this in the last problem. So this is the thing. Now you know the formula for this. It is very simple. What is it? You need to get in terms of, you need to change this in terms of y. So get x to one side. We will change this. X square equals 4y. X is equal to root of 4y. And then limits. Where are the limits in the along the y-axis? It's from 0 to 1. So this is very simple. Substitute in the formula and get it. This is the previous formula. There is no change in this. Okay, but why we did this is we will see in the coming problems, that is B and C, how it changes. I hope this is clear. Over here they have given us the curve, the function y is equal to quarter x square, and then they have given the limit of x is 0 and y is 1. So if x is 0, this is the point. Obviously, y also will be starting from 0. So the limit is 0 and the ending limit over here is 1. So this is the formula of the last topic of the disks. And this is how we get it. But now let's see the next type. Same question. Okay, the answer is 2 pi or 6.28 unit cube. In the last problem I had written wrong, so I changed all the units in the whole presentation. I had an error in all of this. Sorry for that. The volume is always in cube, whereas the last lesson we were dealing with area, which is in power 2. Okay. So now we will move to the next same problem. So you can see this is the same problem, only it is rotated along x-axis. So here it is interesting. Look, here we need to sketch a graph, the same graph. There is no difference. The last problem, the same quarter x square. This is it. But what is the difference now? We are rotating it along x-axis. Last time we rotated along y-axis. It was easy. But now we will rotate along x-axis and we will get a washer. See, this is what is happening. Sorry. See now, over here, I just wanted to show you the difference. Same graph, but along y-axis. Now you can see this is being rotated along the x-axis, sorry, y-x-axis, and therefore we are getting washer. If the same graph was along y-axis, we will just get a regular disk. Now you can see over here, when we rotate this, we will get the top radius and the inner radius. We need to subtract this and we need to find only the wash area. See, now see, you need to understand, don't think a washer is created just because we are like this. It's basically this cross section. Sorry, that's the wrong diagram. Wait, see this cross section over here. Okay, but there is a hollow space that needs to be removed. So as we move along, the hollow space changes based on the function. Okay, so now if I'm drawing over here, this is the cross section, this is the entire cross section, but this is not there. See, because we need only this part, right? So this part and the down part. So the cross section we get is of a washer. So now the formula is different over here. Now we will try solving it up. Write the limits over here. This is very important. Sorry, radii and limits. What is the outer radius? Now we can see over here the outer radius from the x-axis, not the entire length. This is diameter. We need just the outer radius, the big radius from here to here. That is 1. It's given, right? We did the same thing. So then what do? Find the inner radius. So inner radius is basically this equation from here. Okay, it's just the equation. Now we have outer radius, inner radius, the small letter, and now we can find the limits. But how do we find the limit? We know it will start at 0, okay? We know it will start at 0, but where will it end? That is the important question. So we will equate these both, the touching point. See this point where we will just equate these both equation and solve, you will get the answer. Now in the graph, you can see this graph is drawn accurately, so we know, okay, this is 2. But what if you don't draw it accurately? Because you're not going to draw accurate graphs. You won't exactly know, okay, this is going towards 2. No, that's not going to happen. You will know only this value, 1, 0. How will you know this point where it touches the one line and this one where it touches exactly? That's why we need to find the intersection point, because you can't because no one, like, generally we will just draw rough graphs. We are not going to draw, see, it's a rough sketch of graph, not the exact graph. So you don't know this value. This value is found out by equating this line at 1 and this equation. Now you will get the intersecting point. So that intersecting point, quarter x square equals 1. When you solve it, take 4 to the other side, you'll get 4x square. Square root of 4. Whenever you take square root, remember it is plus or minus the answer. So it is plus or minus 2. Now apply, look at the graph. It has already been told for us that, see, this is 0. Okay, we got the intersecting point over here as 2. Okay, that is good. But can you take minus 2? No, we cannot take minus 2. Why? Because the limits have been stated from 0 over here to 1. Okay, this is the part of the graph. You can't go behind. So it is only from 0 to 2 along the x-axis. So the limits are along x-axis. Say x is 0 and 2. So you need to integrate along that axis now. So over here, limits along x-axis will be 0 to 2. Or x is greater than or equal to 0 but less than or equal to 2. Now we can see over here the same graph, but let's solve more. Step 3 is substituting and solving. Now we know this is the formula, outer radius. What is the outer radius? It's 1. Inner radius, x square by 4. And the limit from where to where? It's along x-axis. So x-axis, where is x-axis? The limits 0 to 2. We found, right? We found it in the last problem. So it's 0 to 2, 1 square minus quarter x square the whole square. So this is it. Now we can apply it. You can put it in the calculator and solve it by using this symbol over here. Use this symbol, solve it up. You will get the answer. It's same. You can try it by yourself and check the answer. It'll be 8 by 5 pi. Now this is the answer. Volume 5.03 unit cube. I hope this is clear along y and x. And now let's do one last problem along 2. So now this is something interesting. Along y is equal to 2, line is 2. How do we do this? It's very simple. If you have understood the previous two problems, this is simple. If you have not, please pause the video, go back and then come to this problem. So the solution, as we know, by sketching the graph. Now the graph is the same thing. Look over here. This is the same graph over here, 1, and we found the intersecting point in the last problem, the B problem, as 2. And now y line, see, this is the line. 2 over here you're rotating. So when you rotate it, what is going to happen? It's going to look something like this. See, this part is being rotated. So there is a big hollow space. Same like what we just now saw, inner radius and outer radiuses are formed. Outer radius would be from this, though, you need to consider. So it's a little bit tricky. What happens is whenever you have a certain line like this, whatever is the inner radius or the outer radius, you need to 2 minus that. Okay, wait, I will try to make it simple over here with the inner radius. It's easy to understand. So this is the inner radius of the circle, right? So this is the inside radius, as you can see when you rotate it. What is this point? It is 1. What is this over here? 2. So 2 minus 1. What is the radius actually? It is 1 unit. So this 2 minus 1. Same way, over here the outer radius is this function. 2 minus this function will give you the outer radius. So that is why we use whichever is this line. 2 minus the inner radius minus the outer radius. That is, say 2 minus 1/4 x square, and 2 minus 1 equals 1. So this is how we get it. And the limits over here, we know we just now solved it 0 to 2. We have already solved it. The same method, we have just taken the limits. Now you can use the formula, substitute the formula for 0 to 2, but only difference is this radius. Outer radius is from year to year. Remember, it is 2 minus this equation. Okay? 2 minus the equation is 1/4 x squared, the whole square. And the inner radius is over here 1 at the point line 1, but it's 2 minus 1 because it's from the line y equals 2. That is how we can solve it. Put it in the calculator, get the answer straightforward. So please remember the inner and the outer radiuses. So that is very crucial to solve this washer problems. Now we will solve problems revolving a region about different lines. It may be axes or at specific lines. Here we have a problem where R be the region bounded by y equals 4 minus x square and y equals 0. Find the volume of the solids obtained by revolving R about each of the following axes. That is the y-axis for the first problem. Here, first we need to sketch the graphs. We have already sketched the graph of this previously. Over here, it's a parabola. Now, they have not restricted any limits, so you have to just draw a parabola opening downwards. But y equals 0, this line, okay, where y is 0 over here, that's the limit. So, next thing is you're rotating around y-axis, so that means it will be this. But since they have not restricted anyways, you got this. But let's see what's the radius. The radius is this line over here. So write the equation in terms of y because we are rotating around y-axis. So get everything to the other side and x to one side and you got this over here. How would you know the limits now? Limits are along 0 and 4. See, y is 0, that is fine, but how would you find the 4? Either from the graph because this is the intercept, or you can substitute this as 0 and solve. Square on both the sides, this is 0 equals 4 minus y, that is y equals 4. So that would be the limit. So it's 0 to 4. Now we have this figure. Now all you need to do is substitute the values. We have the limits, we have the equation, substitute it over here because we found the equation of x, okay, equals root of 4 minus y, that is square, and over here pi and 0 to 4. And this is the answer, that is 25.13 unit cube. It's very simple. It is not a washer problem. It is a simple disk problem. This is the disk formula. Now we will see over here the line y equals minus 3. This is very crucial because previously we had solved a problem where we had been given the equation like this and they are told to rotate along y equals 2 or something like this. So what we did the upper equation 2 minus this equation, whatever the equation was over here. It was, I think, 1/4 of x squared. And then this line was something 2 minus 1. So the line was upside. So this line minus the below equations. But now look over here. When we graph that, we just now did it, right? We saw the graph over here. But you're revolving below minus 3. So this will be the equation. See, this is the hollow region. We just need the solid part. It's like a washer now. What can you do? It's very simple. You need to write the radii, right? Remember now in this case, what is the radii? What is this equation? This is 4. Upper equation is 4 minus x squared. You need to subtract this line. See this line. What is this? Minus 3. It eventually becomes 4 minus x squared plus 3. This is the thing. This is important to know. Okay. There are other ways to find the radius, but this is a simpler way. So this equation is stopped. So you're rotating along this axis. So this equation minus this point will give you the outer radius. Now same way for the inner radius. So now what we have done is 4 plus 3 will see over here. After simplifying, 4 plus 3 is 7 minus x squared. Same thing for the inner radius. Now over here, this line, what is this line at? It's y is equal to 0. So it is 0 minus, what is this line at? Minus 3. Okay. So it is 3. Radius is 3 for the sorry, this is the inner radius. The first one, capital R, is outer radius. I'm so sorry for that. Outer radius and the inner radius is 3. Now, how do we find the limits? This is along which axis? Y axis. Sorry, along x axis. I mean, see, it is not along x axis, it is along the line y equals minus 3. Where is the line y equals minus 3? It's over here, right? Minus 3, it's straight. Now, you're revolving similar to the x axis, right? So everything in terms of x. So it's fine. Now this is it. These are the equations. But make sure to find the points of intersection in the graph. You can easily find it if you know exact plotting of graph. But what if you don't plot this graph exactly? You did a rough sketch. Then just equate these two equations. Equate it. So you will find where this line and this equation will touch. That's it. So how do you do it? 4 minus x squared. You can take this x squared to the other side. It is 4 equals x squared. Square root of 4 is plus or minus 2. So the limit will be from minus 2 to plus 2. That is the limit. Now use the formula and solve. The formula is from A to B. Capital R is the outer radius minus the inner radius. The limits we found was minus 2 to 2, 7 minus x squared the whole square, minus 3 squared. Put this in the calculator, you will find it. You can press S and D and you will get the unit. Unit cube is the units. It's 98.13 unit cube because it is volume. So this is very crucial to know which line it is passing by or which axis is it passing by. If it is along the y-axis, you must get all the terms in terms of y. So it will be x is equal to everything in terms of y. Whereas if it's along the x-axis or it's a vertical, see, along any vertical line like this is a vertical line, right? Then you have to get all in terms of x. The derivative will be with respect to x.